extinction on this planet in terms of species is an ongoing process. There are five, they're called the Big Five, five major extinctions in the last 540 million years. I can read the reasons for the Holocene. Oh, the Holocene, does anybody know when the Holocene period is? Anybody? It's right now. We're in what's shaping up to be the largest extinction event that the planet has ever seen. And not only that, but it's one of the most, it's going to shape up to be the most rapid. 50% of the species are dying, are likely to be extinct in the next 100 years, and that's an unprecedented event. And
wasn't that all just taking into consideration that we've sort of categorized and cataloged?
No,
species?
I mean, I don't think so. I mean, I'm not a paleontologist or whatever, but I think that all of, like, this 50% of species and this 50% of species are the same numbers. I think.
And Michael, you know what? Believe it or not, you all, that's all mathematically computable from DNA in current animals. All of that is provable.
Because there's. What's that?
The extinction rate recently is a result of human population. It's a result of one species. The extension of over 50% is.
I know.
But the thing you're not presenting is how many new species have been born.
I don't know the answer to that question. That'd be a great follow-up. I have no idea.
Species are not. It's not like
speciation.
There were X million
well,
species
I will tell you.
And now we're down to.
No, but I will tell you that speciation.
Changing.
Yeah, but speciation occurs at a glacial pace compared to extinction over 100 years. Extinction of 50% of species over 100 years. Speciation itself takes. It doesn't for some species, for bacteria, it doesn't take that long at all.
So couldn't you make the argument?
What was the last?
The death of sapient species, the one and only sapient species,
Would be good for everyone else?
Is likely, is natural, since every other species is died.
Well, let me tell you. I gotta ask you guys a question. If sapience is important, if that's true, and if we know that the Earth itself has a hard stop at 5 billion years when the sun overtakes the Earth's orbit, there's a hard stop at 5 billion years. If sapience is a good thing, and if you accept the premise that we may have squandered, or at the very least used up our endowment of joules of energy in oil and coal, I could make the argument that the next sapient life form is going to have a hard go to get off the planet within 5 billion years, because we've used up a lot, if not all, of the cheap, easy energy. If you disagree with that premise, if you think that there will be cheap energy available to them over that time period,
every 2 years.
What's that?
During the last presentation, we're doubling every 2 years,
Okay,
which implies that we're going to get off. It's exponential, so it's not linear. Just because we haven't done it in the last 5 billion doesn't imply it's going to take another 5 billion.
No, what I'm arguing is that we need to survive the next 1,000 years so that we will be able to get off the planet before the hard stops. And the hard stops aren't just 5 billion.
Why is getting off the planet the solution?
Because the planet is not going to be able to sustain us past 5 billion years. There will be an asteroid event that will lead to extinction.
A lot of the things on your list don't have anything to do with this planet, and are happening everywhere in the solar system.
I'm not sure I understand your argument. Listen, the planet is not going to be able to sustain life sometime in the near future. Near being from now to 5 billion years. Somebody has got to get off of this planet as a sapient being, or sapiens, as far as we know, is not going to be able to survive the next 5 billion years.
Well, we've gotten off the planet.
It's pretty simple.
Michael, we got off the planet. I mean, we've gotten off the planet.
Not far enough. And certainly not in self. And certainly not in self-sustainment.
We haven't figured out how to use it.
Okay. I've only got 20 minutes. Let's just agree to disagree for now, and we can move on
But
from
there's
there.
a lot of validity. What is the KT event?
The KT event was the one that wiped out the dinosaurs, likely a asteroid.
The one in
Cretaceous-
Siberia?
The Chicxulub, that one. That's probably the one that wiped them out. Let's see, the Cretaceous Tertiary extinction event. That's the KT event. The Triassic Jurassic was probably volcanism, global warming, methane hydrates, or all three. The Permian was likely methane hydrates. So I'm just going to skip the rest of that and go to the next slide. Yeah, where is everybody? Over lunch, bunch of physicists on the Manhattan Project, Troy, correct me if I'm wrong, I think that's right, were discussing the Drake equation, which is basically an equation to figure out how many life forms, how many sapient life forms, how many technically advanced civilizations there might be in the galaxy, right? And it's a pretty simple calculation. We could step through it step by step here, but basically, it turned out, well, there's a pretty good likelihood that there should be a crap load of technically advanced civilizations in our galaxy. Like literally thousands, depending on where you do the numbers. Some would argue with that. Some would say that actually there's likely only one, but that's neither here nor there. Because Enrico Fermi brought up this paradox, which is, where the fuck is everybody? Right? They've had 13 point, well, the galaxy's not that old. They've had like 12 billion years. Let's say they've had 5 billion years. So where are they? There are many, many solutions to this paradox. When I say many, there are books and books written about this. We're not going to go through all the solutions. Some of them are valid. I mean, all of them are possibly valid.
If each one is only sapient and technologically advanced for 5,000 years at a time, then you'd have to be pretty lucky for them to coexist at the same time.
That's one of the. That's a perfect argument in favor of this paradox, which would say, you know, we're alone. The other thing would be, well, there's a corollary to Clarke's argument, which is the technical, you know, the sufficiently advanced technology is indistinguishable from magic. There's another one that says sufficiently advanced technological civilization is indistinguishable from nature.
Mm. Say that again? We all recognize
that's so
it.
Awesome, right?
That's so
a sufficiently advanced technical civilization is indistinguishable from nature.
Well, to
That's
point
like-
to
To
that
us.
theory,
And here's the idea,
That's like
right?
a god or
Ants.
No, but
Ants
but
don't know how to
there-
drive.
there's
They don't know
been
anything
some-
about cars. They don't know anything about radio, right? Same thing with us. If it's a sufficiently advanced technology, we're not even going to know it's there. We're going to be like the ants to humans. That's the analogy.
No, but may I just add one thing in order to defend this argument about how it's so correlated to nature? Is there was recently a physicist, and he's not really in the establishment, he's actually a surfer, that came up with this theory, and he has a PhD, that a theory of everything in order to sort of, you know, well, I won't get into it, but he was able to deduce that what it is that sort of links everything together, electromagnetism, gravity, the strong nuclear force, the weak nuclear force, is this idea of E8, which is this like 8-dimensional thing that you see in nature, this perfect corollary that you can see, sort of like the idea of in this golden harmony, this golden rule that's already out there in nature that we just have to see. So it already exists, but we're not able to see it yet.
I actually remember hearing about this. This came up a few months ago.
It came out in November of last year, and then it's been getting a lot of attention because the idea that it's all there, but we haven't opened our eyes to it.
I think he solves it in 8 dimensions, and the other problem is that it's
Yeah.
hard. It's impossible for us to actually directly see those 8 other dimensions. So.
We only see 4, and the rest are curled. Well,
It's the Star Trek phenomena where you think they're all mosquitoes buzzing in our ears, but they're just moving more quickly than we are.
It's funny you should say Star Trek and volcanism, because the next slide points out to you that it's actually quite possible that there are other aliens.
Wow.
They are us. So
Being a porn star.
I just couldn't resist that. Next slide.
You guys saw that
So,
before now.
okay, so my premise is that if we get past the next 1,000 years, we will be advanced enough technologically to survive the next 1,000 to 5 billion years. And the 5 billion stop is, again, when the Earth gets swallowed up by the sun. Doesn't have to happen. Could move the sun, could pull some of the matter out of it, but it would take an enormously technologically advanced civilization to be able to do that, or move the Earth, or move to Mars, or move out of the solar system. But you got to make it past the first 1,000 years to be able to
What
get.
basis could you possibly have to make that claim?
To make which claim?
That if we get past the first 1%, that we're good for the following 99%.
Okay, here's why. Because technological advances are proceeding at an exponential
The
rate.
technological advances
Moore's
also
law.
create larger technological problems.
That's true. And some of those technological problems were on the previous slide. Pandemics, global warming,